Hello everyone and welcome to this presentation on cryptanalysis. And in the world of information, right, we can say that cryptography and cryptanalysis are two sides of the same coin, right? While cryptography is concerned with designing secure communication systems to keep information confidential, cryptanalysis is the science and art of breaking those systems, analyzing encrypted messages to uncover the original information or the secret keys. So, if you understand cryptanalysis, this is crucial not only for attackers but also for defenders, as it exposes the weaknesses in cryptographic algorithms and protocols. So, you need to study cryptanalysis so that we can design stronger systems that are more resilient to attacks, ensuring the privacy and security of digital communications. Right. So we are saying that cryptanalysis is the science and art of breaking codes. Then we also need to explain cryptanalysis attacks that we have. We have ciphertext only, we have non-plain text, we have chosen plain text, and we have chosen ciphertext. Right. So cryptanalysis as the discipline focused on deciphering, in fact, encrypted information without prior knowledge of the key used in the encryption process. So in other words, cryptanalysis seeks to break cryptographic codes and ciphers, revealing the hidden content of the secret key by exploiting weaknesses in the encryption algorithm, the implementation flaws, or the patterns in the data. So methods used in cryptanalysis range from mathematical analysis to statistical techniques to brute force attacks and exploiting human errors. So the ultimate goal is to compromise the confidentiality, the integrity and the availability provided by the cryptographic systems. For example, during World War II, the famous breaking of the German Enigma machine by Alan Turing and his colleagues is a classic case of successful cryptanalysis, which had a significant impact on the outcome of the war. So the four main cryptanalysis attack models are given on the screen, and we are going to explain each and every one in our next slide. So you have a ciphertext only. In ciphertext only attack, the attacker has access solely to the encrypted message, which is the ciphertext, and no knowledge of the original plain text of the key. So the challenge here is to deduce either the plain text or ideally the encryption key using only the information available in the ciphertext. So this type of attack relies on statistical analysis, the frequency analysis, or the pattern recognition. For example, if an attacker intercepts a large number of encrypted emails and notice that certain ciphertext blocks repeat, they may infer patterns about the underlying plain text, especially if a simple cipher like the Caesar cipher or electronic code block mode is used. Right. Then there is non-plain text attack. This one is in a non-plain text attack. The attacker has access to both the plain text and the corresponding ciphertext for one or more messages. So this additional information can be leveraged to uncover the encryption key, the encryption key, or to decrypt other ciphertext encrypted with the same key. So in modern context, if an attacker knows that a certain protocol always starts with a predictable head, they can use this non-plain text to analyze and potentially break the cipher. So this one, we are saying that the non-plain text attack exploits the knowledge of both the plain text and the ciphertext to derive information about the key. So the attacker uses this information to deduce further plain text ciphertext pairs. Right? Then there is chosen plain text attack. So chosen plain text attacks allows the attacker to choose a specific plain text and observe the corresponding ciphertext. This information is then used to analyze the cipher and derive the key. Right. So here we say chosen plain text attack is more powerful, as the attacker can select arbitrarily plain text and obtain the corresponding ciphertext. Right. So usually by interacting with the encryption system, as might happen with a public web service. So this allows the attacker to craft a specific message that can reveal weaknesses in the encryption algorithm or leak information about the key, right? For example, block ciphers that use electronic code block mode are particularly vulnerable to this attack, as the attacker can submit plain text with repeating patterns and observe how these patterns are reflected in the ciphertext. Modern ciphers are designed to resist such attacks, but implementation flaws can still make systems vulnerable. Then we have chosen ciphertext attack, right? So in a chosen ciphertext attack, the attacker can select arbitrary ciphertext and obtain their corresponding plain text, typically by exploiting a decryption oracle or a system that responds to decrypted data, right? So this is the most powerful of the 4 basic attack models, as it allows attackers to probe the decryption system for weaknesses. One real-world example is the padding oracle attack, where an attacker submits modified ciphertext to a server and observe whether the server reports a padding error, gradually revealing information about the plain text. So chosen ciphertext attacks have led to the development of more robust encryption schemes, such as the authenticated encryption, which combines encryption and integrity checks, right? So in conclusion, cryptanalysis is a critical field that tests the strength and the reliability of cryptographic systems. So the 4 main attack models, the ciphertext only, the non-plain text, the chosen plain text, and the chosen ciphertext, represents different levels of attacker capability and access, so each posing unique challenges to cryptographers. So by understanding these attack models, security professionals can better evaluate the resistance and the resilience of encryption algorithms and protocols, anticipating potential weaknesses, and design systems that remain secure even in the face of sophisticated adversaries, right? So this ongoing battle between cryptographers and cryptanalysts drives innovation and improvement in the science of security and securing digital information. So this marks the end of our presentation on cryptanalysis, and thank you for listening to this presentation. Thank you.